So this is a class where we learn Algebra 2 as well as Geometry. So on special request, we are revising some of the concepts of geometry which I had sent in the WhatsApp group. We will quickly look at what are those topics and then we'll go through them one by one to see what we know already versus where you guys would need some help. So let me quickly touch upon all the topics that we want to cover today. Okay? Is everybody okay? No?
Yes, sir.
Okay. So let me read out the topics that we are going to talk about. So we will look at angles of polygons, properties of parallelograms, and then proving some concepts relating to parallelograms, and then look at trapezoid, kite, maybe even rhombus. So these are all two-dimensional shapes that we are talking about. Let me quickly touch upon, let me see, Manvi, can you better sit down please? Let me quickly look at how much we are clear about the basic properties of these shapes. Because geometry, when you talk about, the most important thing is, are we clear about the properties of all these shapes? And if we are, everything else falls in place. Okay? Hello, Sanvita. So, Sanvita, we will do a little bit of geometry today, okay? Because of some special request. This class is for geometry and algebra 2. So, today we are taking a small change and doing a bit of geometry, and then we'll go back to algebra 2 in the next class. Is everybody okay? Now, let me start with rhombus. What all you guys know about rhombus? Real quick. Anybody? What do you guys know about rhombus? Maybe I'll ask Vaibhav or Riyahi. No. Please don't do that, okay? Nobody knows about rhombus? Yes, Anvita.
Its opposite angles are equal.
Okay, let me put it this way. I have a square, all four sides same, all four angles 90 degree. If I pick two corners and squeeze it, it becomes thinner and taller. What does that mean? In a square you have all four sides same, in a rhombus also you will have all four sides same, but the angles will not be 90 degree. The angles here, where you are squeezing it, it will become an obtuse angle, meaning more than 90 degree, and where on the other side it becomes an acute angle, less than 90. But what is important for us to know is all the four sides are same. So if somebody says find out the perimeter for rhombus, not a big deal. You will add four sides, all are same. That's okay. But there is one more property of a rhombus that you need to be aware of, that is the opposite corners when you join them. These are called diagonals. So if this is a rhombus A, B, C, D, A to C is called diagonal 1 and B to D is called diagonal 2. And that has a very important role in finding area of a rhombus. Because the property of rhombus says that the diagonals perpendicularly bisect each other. What does it mean? The diagonals of a rhombus perpendicularly bisect each other. What does it mean? Vaibhav, Samrita, anybody?
I think
What is,
the diagonals are basically perpendicular for rhombus, and also that makes like the angles opposite, right? I mean the opposite angles.
no, I'm just talking about diagonals. I'm saying diagonals of a rhombus perpendicularly bisect each other. What does that mean? Yes, Anvita. at the middle point and make 90-degree angle with each other. So basically, if you have a rhombus, every angle here is 90-degree, and this piece is equal to this piece is equal to this piece. Yeah. This diagonal split this diagonal to two halves. This diagonal split this diagonal into two halves. That's what it means. They are perpendicular bisector of each other. Okay. They are perpendicular and they bisect. Okay. Now that plays an important role. This property, if you know about a rhombus, then if you have a rhombus, the diagonals are perpendicular bisector of each other. What that means is this triangle that you see, this triangle and this triangle is going to be congruent. This triangle is going to be congruent. This triangle is going to be congruent. This triangle is going to be congruent as well. Does it make sense? So what I'm saying here is the diagonals of a rhombus perpendicularly bisect each other, meaning this is a right angle triangle, 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 and all these four are congruent. Look at this one and this one. This side is common. This side and this side are same, and this angle is 90-degree. Theorem of congruence saying RHS, right? For two right angle triangles will be congruent if the hypotenuse are same and one of the side matches. So these two are hypotenuse for these two right angle triangles, and this side is common. Side and hypotenuse matched. Both are right angle triangles. They are congruent. Same way you can see all these four triangles are congruent. What I'm trying to prove here is, if I have a rhombus which has diagonal D1 and D2, they are splitting each other into half, and if I have to find out the area of this rhombus, that will be 4 times the area of one of the right angle triangle. 4 into area of this right angle triangle, which will be this half into base into height. Base is, let's say, this is D1 by 2, and if this is D2, it is D2 by 2. This height is whole thing by 2, so D2 by 2, this whole thing is D1 by 2. So half into base into height. Now you look at it, it makes it D1 into D2 by 2. This whole calculation. That becomes your formula for area of a rhombus. Area of a rhombus is half into D1 into D2, where D1 and D2 are two diagonals. And I am pretty sure everybody is wondering how come all this happened. Yeah? So, when I'm in the class, beta, I need to pay my full attention to what I'm doing. Okay? So please don't make any sound, otherwise I'll be distracted. Okay? Is everybody clear now? I think kids are not clear. Vasundhara, did I make some sense or I did not? Let's come back to this one. So this is a rhombus. What we knew is the two diagonals, the property of the rhombus says the two diagonals perpendicularly bisect each other. Hello, Ananya. So Ananya, we are doing a little bit of geometry today, okay? On special request.
Okay.
Yeah. So we started with the first shape, rhombus. Rhombus is nothing but a squeezed square. When you pick two corners of a square and squeeze it, it becomes thinner and taller. But all the four sides will be the same, like the sides of a square. But the property of the rhombus that we need to be aware of is the diagonals of the rhombus perpendicularly bisect each other, meaning when they meet each other, they meet at 90 degree and they get split into two equal halves. So this side and this side will be same, this side will be the same. If this diagonal is, let's say, D1, this will be D1 by 2. If this diagonal is D2, this piece will be D2 by 2. And what I was saying was, by looking at this, we can see that this triangle and this triangle are same in area, properties, they are congruent. I think your parents are here. No, not here. So this triangle will be congruent, this triangle will be congruent as well. because they have common hypotenuse and a common side. If you look at this triangle and this triangle. Similarly, between these two triangles also, this side same, this side is common. So there is a theorem for congruence of triangles which says RHS. If you are talking about two right angle triangles, if you have matching hypotenuse, this, and one side matching, which is this, they are congruent. So this area will be same as this one. Similarly, you can say that these two also will have same area, these two will have same area. That means we are talking about area of this triangle is 1/4 of the area of the rhombus. So if I have to find out the area of the rhombus, I will say 4 times area of this triangle. Area of this triangle will be half into base into height. This is my base, which is diagonal by 2. What is the height? This diagonal by 2. That's what I put here. So that is how this formula became. Area of a rhombus is half into D1 into D2, where D1 and D2 are two diagonals. Does it make sense, Vaibhav? Vasundhara? Ananya? No?
Yes, sir.
Myra? Aryahi? Anika, okay? Alright. So this is the first thing that we saw. Now I'll try skimming through this one a little faster because I don't want you guys to spend a lot of time figuring out or deriving the formula for the area of different shapes. You would not have to do that, but it's important for you to understand why that came into existence. Now let's look at the next shape, kite. What is that we know about kite? Kite is a quadrilateral, meaning it has 4 sides. But like in the rhombus, it looks somewhat similar to rhombus, but it is not rhombus. The difference being, in the rhombus you have all 4 sides of same length. That is not the case with kite. What happens with kite is, these 2 sides are same, the bottom 2 sides are of same length. Yeah? Now, other property of the kite that you would need to know is, it is symmetric such that, here if you look at the diagonal, this diagonal, and join these 2 cardinals, that is another diagonal, you will find that this triangle and this triangle are congruent, this triangle and this triangle are congruent, and the area of the kite will be equal to area of this triangle plus area of this triangle times 2. 2 times area of, let's say this is 1 and this is 2. Area of 1 and 2. Okay? What happened? Do you see your parents yet? Not yet? Can you sit closer to this one? I'm trying to close the door. If I close it, you'll not feel cold. If I close it, they would not know about the class.
Could you message them? Because we're sitting here.
Okay.
Text my dad.
No, I'm not going to do anything in the middle of the class, okay? Because I have to be fully with the kids. One second. That here. Okay, cool. Sorry kids, just give me a minute. These younger ones are leaving now. Okay, just 1 second. Okay. Sorry for the bit of disturbance. Okay, the kids are gone. Yeah. So now when we are coming to the kite, you will see that this triangle and this triangle, again, the one property is here the diagonals also meet at 90 degree, but they don't bisect each other perpendicularly. Okay, I mean they don't bisect. So angle will be 90 degree, but they don't bisect. As you can see, right, this side is smaller than this side. These two might be the same, but this diagonal, I mean this portion of the diagonal and this portion of the diagonal are not the same. Okay. Am I making it very boring for everybody? Nobody is responding. Is everybody able to follow so far? Okay. So here with the kite, The understanding is all the four sides are not same, unlike the rhombus, but the top two sides and the bottom two sides are same. So when you have to find out the area of this rhombus, let's say if I have to find out, let's say this is, let me give it a name. Let me go quickly. Okay. If I have to find out the area of this rhombus, I will find out the area of this, this and this. But what we see is 1 and 2 are same. These two triangles are congruent. Why? This is a right angle triangle. These two are right angle triangle. This side matches, and this side is common. So it will be 2 times area of 1 and 2 times the area of one of the triangles. So let's say 3. Now look at area of 1. Here to here. Let's say this is O. So area 2 times the area of this. So 2 times area of 1. Area of 1 will be half into base is this one. Now we saw that these two triangles are congruent. So this side will be same. So this will be, let's say this is D1. So this will be D1 by 2. Base into height. Height, let's say, is A to O. We don't know whether this is equal to this or not. Plus 2 times the area of this guy. This guy's area will be what? Again, half into base. This one, OC into height. Let's say this is OD, which is again D1 by 2. So from this, what you see is, it will be 2 times, what all are common here? Half into D1 by 2, half into D1 by 2. So let's take half into D1 by 2 common, and then we are left with AO plus OC. AO plus OC is nothing but the second diagonal. So this became 2 into half into D1 by 2 into D2. D1 to D2 by 2. So all that I was doing was to tell you guys that there is a common formula for finding out the area of a rhombus and area of a kite, and that is D1 into D2 by 2, where D1 and D2 are the diagonals of the kite or the rhombus. I see a pin drop silence. Let's not worry about how is that proved, because you don't have to prove it. But what I'm saying is, if you're talking about rhombus and a kite, both have the same way to derive the area, and that is D1 into D2 by 2. And from a property standpoint, rhombus has the diagonals meeting each other at 90 degree and bisecting each other as well. Wherein in the case of kite, the diagonals only meet at 90 degree. They don't bisect each other, because the top portion of the kite is smaller, the bottom portion is taller. So that's why the same rule doesn't apply here. But when it comes to the formula for finding it out, we saw that in both the cases, the formula for deriving the area of a rhombus and kite is the same, which is D1 into D2 by 2. Aryahi, Sanvita, Vasundhara, are you guys okay? I mean, am I making sense to you guys, or I'm just rushing through it? Bhav, did I make decent sense, or I was getting you guys confused?
Yes, right.
Okay. Now, let's go to the next shape. And that is, okay, let's do one thing. Bhav, you tell me which shape you want to go to. Next one. Trapezoid?
Yeah.
Trapezoid. What do we know about a trapezoid? It has only one pair of lines parallel to each other. Yeah? If I'm talking about ABCD as a trapezoid, only AD and BC are parallel to each other. Correct? And they are not of same length. So this is a unique quadrilateral which has a condition for not matching the sides. If you talk about rhombus, you talk about parallelogram, you talk about rectangle, you talk about square, you talk about kite also. You have something to say, okay, these two things will match, or all the sides will match, opposite sides will match. Here it says trapezoid is a shape where there is only one pair of sides which are parallel to each other and they are not of the same length. So here, if I have a trapezoid and I have to find out the area of a trapezoid, how much that would be? Anybody remember the formula for area of a trapezoid? Anybody? Viswa? Yes, Sanvita, go ahead.
Like the parallel sides added together divided by 2 times height.
So you are saying parallel side, let's say this is x and this is y. So you are saying
X plus y divided by 2 times height.
times height. Height is the distance between the two parallel lines, right?
Yeah.
And do we all know why? Does anybody remember why? Vasundhara, Ananya, anybody? Okay, I'm not trying to put you guys on the spot, I'm just checking. See, the whole concept lies in a simple thing. It's a composite shape. Why I'm saying so is because there's no shape like this, there's no basic shape like this. What we can do is we can split this into one right angle triangle, another right angle triangle, and then a rectangle. Sum of the area of all these, let's say this is x, so here to here will be x, this is h. So what we have done is from these two vertices, we have drawn the perpendicular. So let's say this is meeting at P and this is meeting at Q. So if you have to find out the area of this whole thing, to find out this area plus this area plus this area. Look at this area. This area is what? Half, it's a right angle triangle, half into base, which is BP into height. This is height. And again, these two lines are parallel lines, meaning the distance between the two will always be the same. So the height, here it is height, here also it is height. Half into BP plus H, BP into H, that is this area. Now look at this area. This area will be nothing but, this is the first triangle, this area will be length times width. This is a rectangle, right? So this length is how much? X equal to X times width is nothing but H plus this right angle triangle. What is the area of this one? Half into base. What is my base? Q to C into height, which is H. Now here between the three, you see you have H common in all of them. And 1 by 2 is common in these two. Let's take 1 by 2 and H common. What we are left with is BP. BP is this length plus, now here we took H out and half out. So here we are left with 2 times X, 2X. And then we have a half into H. So here we are talking about QC. Okay. So BP plus this length, which is X. So we have 2 of that plus QC. Now look at this. If I keep half H out, BP plus, put 1X here, plus QC plus X. We have 2X, so I will split that into two parts, okay? 1X here, 1X here. Now BP plus X plus QC. BP plus X plus QC is nothing but by this length, which is this whole thing becomes Y and then X. So the area of a trapezoid is half into height times sum of the two parallel sides. Yeah? Does it make sense? Vaibhav, Sanvita, Mahira, Nanya?
Yes, sir.
Okay. So, again, I know we might not have enough time, to cover all the things that we're trying to cover. But what I'm telling you guys is, any formula that we come across, there's a reason behind. And the most important thing is, we must know that there are properties of every shape that we talk about. As long as we are aware of those properties, we can use those properties, or property as in the information about those shapes, and use that for deriving all the things that we need to derive. Now, let's talk about parallelogram. What is the area of a parallelogram? Anybody remembers the formula for area of parallelogram? Myra, Ananya, Biswa, Anika, anybody? Sanvita, I would give you the second chance. I want to hear everybody, okay? Just let me see who can dare to give me a right or wrong answer. I don't care about the answer being right or wrong. I'm just caring about everybody participating in the class.
So is it like base times height?
Base times height. Okay. Let's get it certified by Sanvita. Do you agree, Sanvita?
Yeah.
Okay. So we have Bhav saying the area of a parallelogram is base times height, and Sanvita agreeing to it. Is there anyone in the class who wants to contest these two kids and say they are wrong? Anybody? Myra, Aryahi, Vasundhara? Guys, be brave, fight it out, it's okay. When you fight and argue, that is when you get to realize whether you were right or your friends were right. And both helps. And okay, let's look at it. Here is my parallelogram. Everybody can see the board, okay, right? Can everybody see the board, okay?
Yes, sir.
Okay. This is a parallelogram. It doesn't look like a parallelogram. I have to do a better job with my drawing. Okay. This is a parallelogram. And as you guys said, area of a parallelogram is base times height. So this is my base. Oh, this is my base. And height is nothing but the parallel distance between the two, perpendicular distance between the two parallel lines, correct? So we are trying to, this is the, let's say this is height. We are trying to find out how come the area of parallelogram is base times height. How about my base remains the same and I draw another parallelogram. Okay, now. See, now you look at this parallelogram and this parallelogram. Both have the same base and the height also is the same. Are we saying that the area of this parallelogram and this parallelogram is same? The formula says so. Let's figure it out. Let's look at. Are you guys getting what I'm trying to prove here? See, area. Based on the formula that I heard from you guys, it says base times height. If I keep my base fixed and the perpendicular distance between the line fixed, can I tilt this parallelogram like this? And that will have the same area? Let's figure it out. Why that formula is to be believed. Now let's do one thing. Let's drop a perpendicular from, let's say this was my parallelogram ABCD, and we're trying to find out the area for that. What we did was we picked point A and D and dropped a perpendicular from those points onto this line. So now let's say this is meeting at P and this is meeting at Q. Okay. Let's look at this triangle between this parallelogram and this rectangle. What is common? This piece, correct? Let me do some color coding so that it makes little more sense to you guys. My parallelogram is ABCD, this tilted one, correct? What I've done is I've dropped a perpendicular from here and from here. Now what I have is a rectangle, correct? This APDQ is a rectangle, correct? Yeah? Ananya, Anika, anybody? At least one of you, if you say this looks like a rectangle, I'll have the confidence to move on. Vasundhara? We had a parallelogram. We picked up the two corners and dropped the perpendicular from these two corners onto the opposite side. So now this is meeting at P, and by extending this line, it's meeting at Q. So this portion that we see here, APDQ, is a rectangle. I'm just wanting to know if it's looking like a rectangle to you guys or not. Yeah? Biswa? Arya is believing me. How about Biswa, Nanya, Vaibhav, everybody? Sundara? Is it looking like a rectangle, beta? The new one? APDQ? It's a rectangle because we have dropped a perpendicular here, right? So this angle is 90 degree, this angle is 90 degree, this angle will be 90 degree, this will be 90 degree. So these are rectangles. Yeah? So now, let me create a clean thing. So between this parallelogram and this rectangle, there is one thing that is common. The common thing is this shaded region. This shaded region is present in your parallelogram as well as the rectangle. Correct? This is common. By dropping the perpendicular from here, when we converted this to a rectangle, the only difference we are seeing is the red one, which was part of the parallelogram before, which is not in our new rectangle, and the dark one that came as an extension because of the rectangle. Correct? So between this parallelogram and this rectangle, this is extra in parallelogram and this is extra in rectangle. If we find out this and this are same, then we can say area of the parallelogram will be equal to area of this rectangle. Does it make sense? See, I have to do a lot of dance and song, okay, to make you guys believe what I'm doing right now. So let me show you guys some more dance moves. So this is the parallelogram. This is the rectangle. I'm saying we are trying to find out the area of parallelogram, and I don't have a way to do it. But by drawing this rectangle, what we see is this shaded blue region is common between this parallelogram and this rectangle. So the parallelogram has this red piece extra, the rectangle has this shaded dark piece extra. If this piece and this piece are the same, then we can say this parallelogram's area is same as area of the rectangle. Does it make sense? Myra, Sanvita, Ananya, Anika. Yeah? Okay. So this was a parallelogram. Drop the perpendicular from these two corners, and when we join these 2 points, this becomes a rectangle. What we are seeing is this parallelogram has this blue piece and this red piece. The rectangle that we see has this blue piece and this extra piece, the dark one that has come into play. So if we find that this red one and this dark one are the same area, then we can say the area of this rectangle will be equal to area of this parallelogram. Because we all know area of a rectangle is length times width. Now, so let's look at this triangle ADP and triangle DCQ. So DCQ is the dark one and ADP is the red one. Okay? Everybody able to follow me so far? Yeah? I mean, this is more to do with the dance and song that I'm doing right now, okay? Now, between these two triangles, if by any chance we can prove that the area of this triangle and area of this triangle are same, then we'll say, okay, fine. That means by area of the parallelogram will be equal to area of this rectangle. And for area of rectangle, we know length times width. We'll use that information. Now, here between this triangle and this triangle, what we're seeing is, okay, this was my parallelogram. What does the parallelogram say? opposite sides are parallel and equal. So this side AB will be equal to DC. Yeah. Parallelogram's property is opposite sides are parallel and equal. So AB equal to DC. That's what I've written here. Now, other thing that we are seeing between this red triangle and this dark triangle is this length and this length are same because these are two distance between the two parallel lines. These two are also parallel, right? That means AP is equal to DQ. And both are equal to the height, basically the height of the parallelogram. Yeah? But let's not worry about height. These two are same. Now if I look at these two triangles again one more time, what we are seeing is, okay, we have dropped a perpendicular, so this is 90 degree, this is 90 degree. So both, we are talking about two right angle triangles, and the theorem for congruence for right angle triangle is RHS. If there are two right angle triangles with matching hypotenuse and one side matching, they are congruent. So these two right angle triangles had the hypotenuse matching because this was part of the opposite sides of the parallelogram, and these two sides also matching because the distance, perpendicular distance between the two parallel lines. So this hypotenuse and this one match. So these two triangles are congruent. That means area of this triangle equal to area of this triangle. So if we find out the area of this rectangle, that will be enough to be equal to area of this parallelogram. Now again another thing. Now if these two triangles are congruent, that means this side will be equal to this side. Now look at this. This side will be equal to this side. So first we are trying to find out how much is this length, how much is the length of this one. Nothing but the equal to the base, because if you look at the base here to here is this plus this. Now this and this are same, so this whole thing is equal to the base. Look at this, BP, let me write it down, BP plus P to C, PC was my base before, base. And PC plus CQ. PC plus CQ is what we are trying to find out. By these two triangles being congruent, we found that BP equal to CQ. So BP equal to CQ. If I replace these two, if I put a BP here in place of CQ, the same thing base. So this the length of this rectangle is nothing but B, the base equal to the base of the parallelogram. So base times this, length times width. My width is nothing but the height of the parallelogram. So it became area of a parallelogram. Area of a parallelogram became base times height. Now you guys must be thinking, why so much is to be done? There is so much because I am trying to break it down for you guys. But in the simplest way, if you look at it, you will say, okay, if I have parallelogram, I can convert it to a rectangle by dropping perpendicular. When I drop perpendicular, if I see this area and this area are same, that means the parallelogram's area will be equal to rectangle's area. Now, we see that these two are congruent because parallelograms opposite sides and the perpendicular distance. So this area and this area are same actually. Now, what is the base of this rectangle? By dropping perpendicular, we say that okay, these two are actually same because we saw they are congruent now. So this and this are same. That means the base of this rectangle or the length of the rectangle, length of this side of the rectangle is same as the base of the parallelogram with whatever we have done. So that will be base times length times width, and that width is nothing but the height, the parallel distance, a perpendicular distance between the two parallel lines. So that is how area of parallelogram is base times height. Did I make sense to everybody, or I was trying to convince myself? Sanvita, Ananya, Aryahi. See, nobody is forced to say yes. My question to you guys was, but again, did I do a decent job of explaining it, or I got you guys more confused? Because I don't do a great job all the time, okay? I mess up many times. Is it clear to everybody? So far, if you look at what we have done, Ananya, okay beta? Ananya, Anika, both of you, okay? Okay. So, what we have done so far is, we were saying that, okay, let's look at some of the shapes and find out how do we derive the area for those shapes. Just by relating it to the property of these shapes. We looked at rhombus. We said, okay, in case of rhombus, the only property that we need to be aware of is the diagonals, all the four sides are same because it's a squeezed version of a square. Sides are same. And the extra property that we need to be aware of is the diagonals meet each other at 90 degree and they divide each other into two equal halves. That is how area for rhombus is 4 times the area of the 4 triangles that it makes, because all the 4 triangles are congruent. From that we found the area for rhombus becomes d1 into d2 by 2. d1 and d2 are 2 diagonals, or the length of the 2 diagonals. Similarly, in case of kite also we saw, we just need to be aware of the fact that the diagonals of the kite also meet each other at 90 degree. They don't split themselves to 2 halves. They meet at 90 degree. And by doing all that drama and circles that I was doing, the area came again as d1 into d2 by 2. So there is a commonality between rhombus and kite in terms of area, which is d1 to d2 by 2. Then we looked at a parallelogram, found that area of a parallelogram is nothing but base times height, and we saw why. And this is a question that I would want you guys to ask me also whenever I tell you guys a formula. I'll say, okay, you know what, area of this is this. No. I owe you guys an explanation of why that formula came into existence, and I should be able to explain that to you. If I'm not doing it, that means I'm not prepared. Either I should buy time or you should find a better teacher. Okay? Alright? Clear? Now, I'll go back to Vaibhav now. So Vaibhav, tell me, what are the other things that you would want me to explain conceptually? I mean, I'm just disclosing that in public. So Vaibhav is the one who said, okay, can we, since you said this class is for geometry, algebra both, can you explain me some of the concepts relating to geometry? I thought, okay, maybe it will be a good idea to get a refresher, right? Because I've been bothering you guys with algebra 2 for some time. Except Vasundhara, this is Vasundhara's first class, but we thought, okay, let's do a refreshing geometry session and then we'll go back to algebra 2, okay? So Vaibhav, tell me what else you would want me to cover?
I'm good, sir.
You're good?
Yeah.
Okay. Now, let me, since we're talking about geometry, okay, geometry, I mean, I should not show that bias, but eventually geometry is one of my favorite subjects because it's more visual in nature. I can relate to the concepts better. Now, let me tell you guys one interesting fact. So like we were talking about it, right? That if I have, let's say, just now we learned that, okay, area of a parallelogram is base times height. That means, let's say, what does a height mean? Height is nothing but the perpendicular distance between two parallel lines. That means if I keep my base fixed, let's say if I keep my base fixed and there's a parallel line. If I'm drawing a parallelogram like this versus, let's say, CD, versus I'm drawing a parallelogram like EF. Okay, my base is same, perpendicular distance is also same, versus RS versus this. Look at these three parallelograms. This one, this one, this one. They all have the same area because your base is the same and the perpendicular distance between the two parallel lines are the same. So it becomes more like a playground that you can keep your base fixed, keep hovering this around these parallel lines, And every parallelogram that you come across, they will have same area. So you're not able to change the area if you keep your base same and the parallelograms are drawn between the between the pair of parallel lines. So is the case with triangle also. See, let's say you have A and B as 2 points. What is the area of a triangle? Half into base into height. Look at this triangle versus 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 this triangle. All have the same area because your formula says half into base into height. So when I was your age, right? When I was your age, as old as you guys are right now, 30 years ago, right? 35 years ago. Okay? So when I was your age, when I saw this concept for the first time, I was scratching my head. And that is when I started losing my hair. That they don't look the same. They look very different. So how would I believe that this thin and lanky looking triangle has the same area as this guy or this guy? And it takes a little bit to digest that fact. It's a more of a conceptual thing than anything being imposed by a teacher. Okay? Let's look at it. Let's look at the concept part of it. Let's say I have this triangle and I draw another triangle. I mean, I pick up the points as that this angle and this angle are same. At least we can pick up simple example. Let's say this was my AB and this is my CD. If you look at this triangle and this triangle, only thing common between, I mean, there are two things that is common between these two triangles. They have the same base. Area of triangle is half into base into height. So as per the formula, both are supposed to have the same area. Let's look at it geometry wise also. Let's first convince ourselves. Now if you look at this triangle and this triangle, what you're seeing is this part is common between them. If by any chance we can prove that this triangle and this one. If by any chance we can prove that this triangle and the blue triangle and the red triangle have the same area, or if they are congruent, then we can believe that, okay, if you are drawing triangles between two parallel lines with the same base, their area will be the same. This is the simplest example that we are trying to prove. Okay, it will be easy to prove visually as well as mathematically, and then we can extend that to make that as a generic rule. Yeah, is everybody okay with me so far? Nobody is in a search for a better teacher. I know Myra doesn't have a choice, but everybody else, Ananya, Nika, nobody is searching for a teacher, right, on Google right now? No, okay. No, I'm just kidding. I'm just trying to make sure that I have everybody's attention here. So here, this red triangle and this blue triangle, if by any means we can prove that these are congruent, that will help us believe that this formula, I mean this concept of two triangles with the same base and between two parallel lines will have the same area. Let's look at it. See, what you see is this angle and this angle will be the same. These two angles. This one will be the same because this is joined by two intersecting lines. Opposite angles are always same. That is fine. And these two are perpendicular lines, right? So this whole thing is 90 degree. This whole thing is 90 degree. And the way I was drawing it was, I said this angle is same as this angle. So that we draw perpendicular lines. So this angle same. So this angle and this angle will also be the same. So you have three matching angles between these two triangles. I mean, if this angle and this angle is same, that means this angle and this angle will be same, because these two are adding up to 90. So these two are same, these two will be same. This angle same, this angle same. Third angle have no choice, but they will be the same. Now this side is matching. This side and this side are same length because these are perpendicular lines, perpendicular distance between the two parallel lines. So here you will apply a theorem of congruence called ASA. Angle, side, angle, meaning two angles and the side between them. Here all the three angles are matching. So this angle is same as this angle is same as this angle, and the side between these two are matching. So these are congruent. So now this is holding a little more water. We can believe that if you have the same base and you are drawing two triangles, any two triangle with the same base and the tip of the triangle falling on the line parallel to this one, they'll be congruent. Though we picked up an easier example, but that was just to make sure that we are able to prove this visually, and then we can extend this information. So there are two ways you can do it. One is by saying, okay, these two triangles have the same base, same height. Area of a triangle is a universal truth, half into base into height. That is one way of looking at it. Second way is, forget about the area part, the formula part. You can prove this geometrically as well. Now some of you, if you are struggling to recall, what is this theorem of congruence that I am talking about? There are 4 theorems of congruence. Let me repeat that for everybody's benefit, so that if I start blabbering about those theorems of congruence, it should not haunt you guys, because Halloween is over. Okay? Anything haunting has to wait for next year. So I'll keep it lighter, easier. Does anybody know what do I mean by congruence? Anybody? What am I trying to talk about? Sanvita, Ananya. I know Sanvita, I stopped Sanvita a couple of times saying I want to give chance to everybody. That doesn't mean I'm trying to mute anybody. Okay? So if you know something, please don't hesitate. What do you mean by congruence?
Same shape and size.
Same shape. I will go one extra level, saying, okay, if I say two things are congruent, they are exact copy of each other. They have everything matching. Okay? So in my wildest dream, I will not even dare to say Vaibhav and Biren are congruent. We cannot be congruent. We don't have matching properties. Correct? So whenever we say two things are congruent, they have to be exact copy of each other, not even the tiniest of a difference. Okay? Yeah? So congruence is nothing but same. Exact copy, each and every property matching. That's what it means. So congruence is such an important thing that you will deal with every now and then. That's why the mathematicians came up with the 4 theorems of congruence with respect to triangles. Say, okay, fine. If you want to ever prove that two triangles are same or congruent, there are 4 theorems that you can leverage. And they are called SSS, SAS, ASA, RHS. Where S stands for side, A stands for angle. So now if you look at the first theorem of congruence, it says if you have two triangles with each and every side matching, meaning two triangles, one side of triangle A, one side of triangle B matching. Second side of triangle A, second side of triangle B matching. Third side of triangle A, third side of triangle B matching. They are congruent. That means every other property will match. The other angles will match, their area will match, whatnot. HL, we'll come to that. So HL is nothing but RHS. Okay. So this is for every triangle. SAS, side, angle, side. If you have two triangles, if you have this side matching, this side matching, and the angle between them is matching, then everything else will match. This is the second theorem. And in my previous classes, I have proved these theorems also. Okay, it's not that I'm asking you guys to memorize it. We will go back to the breakdown of it, and I can explain that to you guys one more time, why these theorems are to be believed and how much merit do they have. But we will come to that. But from a usage point of view, SSS, all sides, two sides and the angle between them, two angles and the side between them, and RHS. This is a unique one, only specific to right angle triangle. Here you say A is an angle, side, S is a side. Here R stands for right angle triangle. So if you have two right angle triangles, what this says is two right angle triangles will be congruent if they have matching hypotenuse and another pair of matching sides. So you're not talking about, here you look at it, you're talking about three sides, three properties. Side, angle, side, again three properties. Angle, angle and side, three properties. This one is talking about only two properties, only hypotenuse and one on the side. So if you have, let's say, this triangle as a right angle triangle and this is a right angle triangle, if your hypotenuse are matching and one on the side, let's say this side is matching with this side, you're good. You can assume that every other property will match. That's what this theorem says. And we'll keep on using these theorems of congruence very, very, very often because these are the backbones. Like to the younger ones, I say, tables are the backbone. If you know tables well, you can play with math. Likewise, for kids of your age, these are the backbones. You will use them in geometry, trigonometry, I'll not say algebra, but you'll use it in these two places very extensively. Alright? Did I scare anybody? If I did, come to the classroom, you'll get candies. I'm just kidding. Okay? And you'll get candies, not a problem. Halloween candies are still there. I don't eat chocolates anymore. But yeah, on a serious note, I hope whatever we did was a good ride. Yep. Anika, it was a surprise for you, beta. Algebra 2 class, I'm teaching you geometry, but it's Algebra 2 in geometry for everybody, okay? So, whenever you guys come across anything that is tricky, that is little difficult, something that you want to learn ahead of schedule, let's say I'm doing Algebra 2 and you need some help on geometry. If I'm doing geometry and you need help on some topics that you're coming across in your test or in your class and you're grappling with it, don't hesitate. Send me a message at least a day in advance so that I can prepare and talk some sense. Yeah? Pin drop silence. Okay, alright. I know everybody is hungry for the dinner. Have a good dinner, take good rest, and wait for the assignments and the video. Request you guys to watch the video of the class and then try attempting those assignments and let me know if you have any questions. Alright? We'll resume with Algebra 2 in the next class.
Bye.
Bye bye. Bye bye. Bye bye. Bye bye. Bye everybody.